Pluto had it coming from the start. Pluto's trajectory intersects with that of another planet. Pluto, the mysterious small planet at the far reaches of our solar system, is generating excitement in the realm of astronomy. Recent updates suggest a possible encounter with Neptune, raising alarms among scientists and space enthusiasts. Prominent figures like Neil deGrasse Tyson and Michio Kaku have expressed concerns about the implications of this celestial event. But how did Pluto end up on a collision course with its neighboring planet, and what could this cosmic clash mean for life on Earth? Join us as we uncover how something enormous recently collided with Neptune and how scientists have been left troubled by this celestial anomaly. Pluto, once celebrated as a full-fledged planet, underwent a transformation in its status, being reclassified as a dwarf planet due to its unusual orbit. Despite this reclassification, Pluto continues to fascinate and intrigue the astronomical community. Recent forecasts from renowned scientists like Neil deGrasse Tyson and Michio Kaku have raised concerns about Pluto's path potentially intersecting with Neptune's, hinting at a looming threat of collision between the two celestial bodies, which could have significant consequences for Earth. Pluto's journey around the Sun stands out due to its distinctive characteristics within our solar system. Its orbit is exceptionally lengthy, spanning an impressive 248 years. Since its discovery in 1930, Pluto has yet to complete a full orbit around the Sun. Adding to its intrigue is the highly elongated shape of its orbit, which differs from the more circular paths followed by the major planets. Furthermore, Pluto's orbit deviates by 17 degrees from the ecliptic plane, giving its path a steeper incline compared to other planets. The combination of Pluto's inclination and its elliptical orbit introduces layers of complexity to its orbital pattern. One notable aspect is its periodic intersection with Neptune's orbit. For around 20 years during each orbit, Pluto ventures closer to the Sun than Neptune, defying expectations based on their respective positions in the solar system. Delving deeper into Pluto's orbit, it's captivating to note that it's not a perfect circle but rather an elongated ellipse resembling more of an oval shape. This unique orbit results in significant variations in Pluto's distance from the Sun throughout its journey. At its closest approach, Pluto comes within about 30 astronomical units, AU, of the Sun, while at its farthest point, it reaches over 49 Australian dollars away, almost twice the distance of Neptune from the Sun. Moreover, Pluto's orbit is inclined at an angle relative to the orbits of the major planets in our solar system. This inclination not only contributes to the complexity of its orbit but also plays a crucial role in its interactions with other celestial bodies, particularly Neptune. When Pluto crosses paths with Neptune, their gravitational tugs influence each other, altering their trajectories over time. The intricate dance between Pluto and Neptune underscores the dynamic nature of our solar system. While Pluto was once considered a lone wanderer in the outer reaches, its close encounters with Neptune highlight the interconnectedness of celestial bodies, each exerting gravitational forces that shape the paths of others. In recent years, advancements in observational technology have allowed astronomers to track Pluto's movements with greater precision. This has led to a deeper understanding of its orbit and its potential implications for the stability of the outer solar system. While the likelihood of a direct collision between Pluto and Neptune remains low, the possibility cannot be entirely dismissed, prompting continued monitoring and study by the astronomical community. Despite its small size and distant location, Pluto continues to capture attention and curiosity among scientists and enthusiasts alike. The question arises, why hasn't there been a crash between Pluto and Neptune? The answer lies in the gravitational influence of other planets. Astronomers began studying Pluto's path soon after its discovery, and its trajectory puzzled them. Unlike most planets that remain close to the same plane as they orbit the Sun, called the ecliptic plane, Pluto stands out with its steep angle and oval-shaped orbit. The mystery deepened when they realized Pluto's path intersected Neptune's. Despite these complexities, Pluto's orbit remains stable, showcasing the intricate mechanics of space. Understanding how three celestial bodies, like Pluto, Neptune, and the Sun, move and interact gravitationally is a significant challenge. It's like trying to predict where they'll go based on where they start and how they pull on each other. For Pluto, this challenge reveals how its path, Neptune's path, and the sun's pull all work together. Terms like apsidal libration, latitude libration, and the VZK oscillation help scientists solve this cosmic puzzle. Apsidal libration is crucial for maintaining planetary orbits. When Pluto crosses Neptune's path, it's at least 90 degrees away, keeping them from colliding. Latitude libration ensures that when Pluto nears Neptune or other large planets, it's well above their path, reducing the chance of a collision. The VZK oscillation, named after scientists von Zeipel and L. V. K., explains why Pluto's orbit seems unusual but remains steady over time. Despite the apparent chaos in space, certain patterns and rules maintain order. These rules keep Pluto's orbit stable, preventing collisions with Neptune or alterations in its path. The concept of orbital chaos, demonstrating how a celestial body's path is highly sensitive to its initial conditions, illustrates this well with Pluto. Even minor changes in its position or velocity can significantly impact its orbit over extended periods. However, even with this chaos, Pluto's orbit remains stable for an extremely long time, like billions of years. This suggests that even though Pluto appears erratic, its journey around the Sun follows a form of order. Predicting what will happen with planets like Pluto, which have irregular orbits, is challenging. These systems are so unpredictable that making long-term forecasts is difficult. Simulations assist in understanding potential outcomes, but they also reveal that perfect predictions are elusive. These models require precise starting points and simulate complex dynamics. Even a small error can lead to entirely different results, making accurate predictions challenging. Understanding Pluto's orbit is crucial, especially when considering whether it might collide with Neptune in the future. This knowledge helps us better comprehend the workings of our solar system. Pluto's orbit demonstrates how seemingly erratic paths can achieve balance due to gravity and the dynamics of space. It's essential to continue monitoring and studying these phenomena to understand our place in the universe. Exploring space reveals that things can be unpredictable, and Pluto's orbit is a prime example of this unpredictability. Pluto's orbit differs from those of other planets. It's more oval-shaped, meaning it's not a perfect circle. At times, it even gets closer to the Sun than Neptune does. This can make things complicated because Neptune is also moving along its path. There's a slight chance that Pluto and Neptune could collide at some point. Despite its irregular orbit, Pluto manages to keep a safe distance from Neptune most of the time. This is due to something called gravitational forces. Gravity is like an invisible force that pulls objects toward each other. So even though Pluto and Neptune might seem to be on a collision course, their orbits are precisely choreographed dances governed by the pull of gravity. Pluto's orbit teaches us that space is full of surprises. What seems chaotic at first can be a delicate balance of forces. By studying Pluto's orbit, scientists gain insights into the intricate mechanics of our solar system. Continuous monitoring and evaluation are crucial for enhancing our comprehension of the universe and our position within it. Picture a scenario where Pluto and Neptune were to intersect. Such a cosmic event would create ripples through our grasp of the solar system. Although progress has been made in space exploration, Pluto's status underscores that there remains much to discover. Analyzing how large planets influence Pluto's path provides important insights into the mechanics of our entire solar system. It illustrates that the location and movement of each planet can affect the trajectories of other celestial objects. Despite the complexity of space, some leading experts worry that Pluto might eventually collide with Neptune, raising questions about the reasons for this possibility, even if it seems unlikely. Neil deGrasse Tyson, a prominent space scientist, has intriguing perspectives on Pluto. He suggests that reclassifying Pluto as a dwarf planet rather than a major planet like Earth is a step forward. Tyson believes that we are continually uncovering new aspects of celestial mechanics. He interprets Pluto's unusual orbit as evidence of our incomplete understanding. Tyson finds the enigmas of space thrilling and contends that major events like Pluto's reclassification can stimulate public interest in astronomy. He aims to help people appreciate the fascinating and sometimes peculiar nature of space dynamics. Tyson collaborates with other scientists to alert the public about potential risks associated with Pluto's atypical orbit. After thorough investigation, He is concerned that Pluto might eventually collide with Neptune, which could pose significant challenges for our solar system. Such a collision would be rare and consequential, releasing immense energy and potentially shattering Pluto. Debris from the impact could scatter through space and affect other planets and moons, with Neptune possibly experiencing changes in its trajectory as well. Renowned theoretical physicist Michio Kaku believes that a collision between Pluto and Neptune would be an extraordinary and uncommon cosmic event. Kaku views such a collision as a valuable chance for scientists to gain deeper insights into our solar system's dynamics. He argues that while the likelihood of such a collision is minimal, the knowledge derived from studying such a rare phenomenon could be profoundly beneficial. Kaku emphasizes that this would not only improve our understanding of planetary orbits, but also offer more profound insights into the formation and evolution of our solar system. He asserts that the scientific community must keep a close watch on Pluto's orbit to be prepared for any unforeseen changes. As our observational technologies advance, Kaku believes we continuously uncover new facets of our solar system that challenge our existing knowledge. Despite the low probability of a collision, Kaku advocates for ongoing research and vigilance, as even slight changes in the orbits of celestial bodies can have significant implications for our understanding of the universe. To fully grasp the complexity of Pluto's orbit, it is crucial to consider the various forces at play within the solar system. The gravitational influence of other celestial bodies, such as the gas giants Jupiter and Saturn, also affects Pluto's trajectory. These massive planets exert considerable gravitational forces, which can subtly modify the paths of smaller objects like Pluto. This highlights the interconnected nature of the solar system. Even distant bodies can influence each other's orbits through gravitational interactions. Jupiter's immense gravity, in particular, can create ripples in the orbits of nearby objects, occasionally altering their paths in unexpected ways. Besides these gravitational interactions, the presence of other trans-Neptunian objects, TNOs, and Kuiper Belt objects, KBOs, adds further complexity. The Kuiper Belt, a region beyond Neptune, is populated with numerous icy bodies and dwarf planets, including Haumea and Makemake. The gravitational effects of these objects can lead to perturbations in Pluto's orbit. Studying these interactions helps scientists understand not only the dynamics of Pluto's orbit, but also the broader structure of the outer solar system. One intriguing aspect of Pluto's orbit is its interaction with the solar wind, a stream of charged particles emitted by the Sun. Although Pluto is far from the Sun, the solar wind still influences its atmosphere. When Pluto's orbit brings it closer to the Sun, its atmosphere can expand due to increased solar radiation, making it more dynamic. This interaction contributes to the fascination with Pluto as a subject of study. The way its atmosphere responds to solar changes offers insights into how distant celestial bodies interact with their local stellar environment. Moreover, Pluto's relatively recent flyby by NASA's New Horizons spacecraft in 2015 provided a wealth of data that continues to shape our understanding of this distant world. New Horizons captured high-resolution images and gathered various measurements of Pluto's surface and atmosphere, revealing unexpected details such as vast ice plains, towering mountains, and possible signs of cryovolcanism. These discoveries have transformed our views of Pluto, showing that it is a dynamic and geologically active world rather than a static frozen relic. The implications of Pluto's complex orbit and its interactions with other celestial bodies extend to our understanding of celestial mechanics. Studying these interactions contributes to the broader field of dynamical astronomy, which examines how objects move under the influence of gravity. By analyzing the intricate movements of Pluto, Neptune, and other solar system bodies, scientists gain insights into the principles governing orbital mechanics and stability. This knowledge is essential for predicting the future movements of celestial objects and understanding the long-term evolution of planetary systems. In terms of planetary defense, examining objects like Pluto is also relevant. While Pluto itself does not pose a threat to Earth, understanding the behavior of small bodies in the solar system helps scientists develop strategies for monitoring and mitigating potential threats from other objects. Insights gained from studying Pluto's orbit can be applied to tracking near-Earth objects, NEOs, and predicting their future paths. This forms part of a broader effort to protect Earth from potential impacts by asteroids and comets. The scientific community remains vigilant in observing Pluto and other distant objects. Future missions and telescopic observations will continue to refine our understanding of Pluto's orbit and its interactions with the solar system. Upcoming space missions, such as potential explorations of other Kuiper Belt objects, will provide additional data that could reveal more about the early solar system and planetary system formation. Beyond its scientific significance, Pluto's story also underscores the importance of public engagement in astronomy. The reclassification of Pluto as a dwarf planet sparked widespread interest and debate, illustrating how scientific discoveries can captivate public imagination. Educational programs and outreach activities centered on Pluto and similar celestial objects help foster a greater appreciation for the wonders of the universe and inspire the next generation of scientists and explorers. Overall, the study of Pluto's orbit and its potential interactions with Neptune provides valuable insights into the dynamic nature of our solar system. By continuing to explore and monitor these distant worlds, scientists advance our understanding of celestial mechanics, planetary formation, and the broader cosmic environment. Ongoing research into Pluto and its interactions with other planets highlights the complexity and interconnectedness of the solar system, revealing a universe that is both intriguing and ever-changing.